Hey everyone, I just wanted to make this relatively short video, I think, about what outliers are and how we calculate them. So let me head over to the notes. And if you look, this is just below standard deviation here. So outliers. An outlier basically means something that is unusual. It means a data value that is unusual. This can mean a couple of different things. It can mean a data value that is far away from the rest of your data. It can mean a data value that's far away from the mean. It can also mean a data value that is far away from what we expected. Those are kind of all the same thing, but not necessarily exactly. The one we're going to use right now is far away from the center of the data, basically. And so you can see that our definition of outlier, at least for this section, and I'll give you another one in a little bit here, but the one we're going to use for right now is the 1.5 Iqr rule. So here's the idea. If you have a set of data, so let me whip up a whiteboard here. If you have a set of data that looks like this, I'm going to make a box plot for it because this goes well with it. No numbers here, but so there's my number line, right? And so here's my box plot. Something like this. All right, let's say that's what my box plot looks like. This is my x-axis down here. Then an outlier is anything that is more than 1.5 times the IQR above Q3 or below Q1. Now, the way you want to visualize this is in terms of distance. So the IQR is actually visible on a box plot. It is the distance from here to here. Right, that's Q3 minus Q1. I'm having a little trouble drawing, pardon me. That right there is the IQR. So if I go 1.5 times that distance above Q3 or below Q1, we get what are called the inner fences. So let's do this. So how far that is, like that. So if I do 1.5 times that, it's like this far, like here. So you can't see me doing this with my hands, but I am. And then it's like down here. Right, so this distance right here, that's like 1.5 times IQR. And so is this approximately. I mean, if you're doing it with actual numbers, it'd be exact, but when I'm just drawing it on the screen, it's approximate. Okay, so I've got 1.5 times the IQR below Q1 and 1.5 times the IQR above Q3. And so those things right there, these are the inner fences. There's also outer fences for 3 times IQR, but we're not going to use those. Right, so those guys are called the inner fences. And anything that is outside of that range is considered an outlier. That's our mathematical definition of outlier. So any data value that we see outside here. So let me switch colors. Magenta, I like magenta. Outliers. Nope. So all the stuff over here are outliers. Right, so you can see anything that falls outside of the inner fences is called an outlier. And really, all we're saying is anything that's sufficiently far away from the middle of the data is an outlier, with middle here being defined as all the, like the middle 50%, right? So anything that is far enough above the top of the middle 50%, so far enough above the 75th percentile, or far enough below the 25th percentile, is considered an outlier. One thing I want to point out is I deliberately drew this data set so that it would have an outlier, right? It has at least some data out here, because it goes out here, right? And so this right here is the minimum value of our data set, and it is outside the inner fence. So this data set has an outlier in it. It's right here. All right, so that's an outlier. You can signify that specifically on a box plot. I'm not going to worry about that right now, but that's how we calculate. The way you want to think of an outlier, though, is, well, I'll talk a little bit about them in just a second, but that's the way to calculate them. There is another formula that we use much later in the course, like at the very end. We're going to use a formula that says essentially the same thing, or not. It says something very similar. And generally speaking, if something is an outlier with this formula, it's also an outlier with the other one, and vice versa. Not 100%, but they're pretty similar in the things they consider outliers. And that is 2S. So remember that S is the sample standard deviation of a data set. And anything that is more than 2S above the mean or more than 2S below it is considered an outlier. That is a definition that actually goes a lot better with what we do in the rest of the course. So I don't know why the book uses this particular definition here, but they do. And it's fine. This is another semi-commonly used definition. And like I said, it's pretty similar anyway. But for right now, we're going to ignore the 2S one. We're going to come back to that much later when we're doing linear regression, way in chapter 13, 12 or 13. I always forget which chapter that is. But yeah, so let me show you an example of determining if something is an outlier. Yeah, so let's do that. So I'm going to go ahead and go back to notes. All right, so the data set from problem 14 was, where was it? This one right here, the make a box plot by hand one. So for this, what we need to do is we need to find the IQR. We need to find Q1, Q3, and the IQR, and then see if anything is more than 1.5 times IQR below Q1 or more than 1.5 times IQR above Q3. So let's let me get a little space here, and we'll just go ahead and do that. And I'll kind of go through this a little fast since we did this before. But the median was 34. It was right here. That's I'll call it Q2 here since using quartiles. Q2. Q1 was 26, I believe. So there are 13 things. There's 26 in the data set. There's 13 things below Q2 and 13 things above it. So the 7th position, 1, 2, 3, 4, 5, 6, 7. Yes, 26. 26. That's Q1. Q1. And then 1, 2, 3, 4, 5, 6, 7, 40 is Q3. Q3. Okay. So with those things in mind, the IQR is Q3 minus Q1. So we've got IQR 40 minus 26 equals 14. 1.5 times the IQR. 14 times 1.5, which is 21. And so what I'm going to do is do Q1, 1 minus 21. So I'm going 1.5 times the IQR below Q1, right? Q1's 26. So that is 26 minus 21, which is 5. And I'm going to do the same thing above Q3. So Q3 plus 21 is 40 plus 21, which is 61. And so anything that is further to the left, or that is to the left of 5 or to the right of 61, is considered an outlier in this data. So there's nothing to the left of 5. The smallest thing in this data set is 19. So there's no outliers on the low end. But there are some on the high end, right? 61 would go right here, and we've got two outliers. 63 and 82 are both outliers here. So these guys, outliers. I should have done it in magenta, but those guys are both considered outliers in this data set. So yes, there are a couple of outliers in here, and they are those two. So that's it. That's how you calculate whether something is an outlier or not. We'll actually use this a little bit in the future, but for right now, I think that's all I wanted to say about outliers. Let me just quickly check the notes. I'm going to go ahead and clear this off. Yeah, you can just pause this if you want to look at that. Clear all the drawings and scroll down. Yeah, okay. So there is one more thing that I want to say about outliers, and it's actually something that is really important if you're actually doing statistical research, which is outliers are either, they fall into one of two categories. One category is a measurement error, something that is like, so let me give you an example. I have data for how many people use the math lab during various different days, right? And we're eventually going to use a statistical test on it, on that data to see if in general about the same number of people come on all the days. Within that data set, though, there is a weird number where, so it's like 200-ish, it's like 150 to 200 per day on average. Go to the math lab. And so if you look through the data, 150, 160, 180, 220, right? A bunch of different numbers in that range. And you get to one that's like 74. And so the women who run the math lab, or one of the women who runs the math lab, Allison Chapin, I talked to her about that. I said, hey, what happened here, right? Like, it's clearly an outlier. It's something that's wildly different from the rest of the data. So I went and asked her, what happened here? And she said, oh, the login computer broke at noon that day. And so people couldn't log in or could only log in before lunch, basically. So that is an example of an outlier that when you're analyzing the data, you should just toss out. Just ignore it, pretend it's not even there. That's a measurement error, right? That's not what we're trying to measure. Like it just wasn't the right number of people. It was just a measurement error for that day. On the other hand, the other category of outliers is the really unusual but interesting data value, right? It's not measured wrong. It's just different than the others. So for instance, let's say I wanted to analyze the incomes of people in Santa Barbara, or people who live in Santa Barbara. Most of them are going to be near the average. Most people who live around here make about a normal amount of money. Some people don't. Some people are very rich, right? Oprah lives around here. Ellen DeGeneres lives around here. They make tons of money. I guess they're in Montecito, but you get the idea, right? They make tons of money. So most people are down in the whatever $50,000 to $100,000 range, right? Something in that general vicinity. But some people are up in the like $10 million a year range. Very few of them that are far away from the rest of the data. And you don't want to get rid of those necessarily, right? Like if you're trying to analyze the data, getting rid of the outliers in this case gets rid of the interesting character of the data, right? The people who make tons of money are often the people that you're going to be most interested in, right? Nobody cares how much money I make, but you might care how much money Ellen DeGeneres makes, right? Because she's just a more interesting person. And so that's an example of where you don't want to throw your outliers out. So there's no hard and fast rule about what to do with outliers. Some people just like to default to throwing them all away. In fact, I've usually found that most of my students like to, as soon as they identify an outlier, they just want to chuck it out of their data set. Don't do that. Really think about what you're doing. Oh, did I use the same examples I have right here? I did. I suppose that's not a coincidence, but I wasn't intending to read from here. But you have to determine on a case-by-case basis whether you leave an outlier in your data set or throw it out and why. right? And you have to figure out why you want to do that. And it's always related to, well, what am I trying to do with this data? And so I'm going to leave it at that. But I will just say that outliers are either in your data set, they're either going to be ignored or the most interesting thing in the data set, basically. Those are really the only two choices. You don't get any outliers that are just like boring, right? Things that are outliers are really, really neat. In fact, I have literally right next to me on my bookshelf, this book. I don't know if you can see it. It's called Outliers. It's a really good book. It's by Malcolm Gladwell, who's a really interesting author, and he's using it in the interesting sense. In the sense that like the things that are outliers are really interesting, and he's using it as like exceptional people, right? People who are very different from normal people, but in an exceptional way. So if you're interested in reading that book, I'm happy to loan it to you if I ever see you in person and not just on a computer screen. But you are also, well, like it's widely available and not that expensive. If you just want to buy a copy, and it's a great book. So anyway, I think I'm going to stop there. I'll go ahead and stop sharing here. Just leave you with that book recommendation. And I think that's all I want to say about outliers. So I'll go ahead and end the video now, and I'll see you in the next one.